Hello, welcome to Chapter 9, homework questions 70 through 76. Represent the solutions to the inequalities below in the number line. I have four number lines drawn to help us out a little bit here, but A is 3x minus 2 is less than 10. So we want to solve this as an equation. That's supposed to be a 10. And we have 3x is equal to 12, because once again we want to change the inequality to an equation, divide by 3, and we get x equals 4. So on our number line, at 4, we got to decide, is 4 part of the solution or not part of? But because it's not equal to, it's just less than, then we need to do an open circle at 4. And now we need to figure out, are we going to shade to the left? Are we going to draw our line to the left or to the right? What are our solutions that we're looking at? So once again, the easy point to test is x equals 0. So that's the one we're going to test. We're just going to plug it into the original inequality. 3 times 0 minus 2 is less than 10. 0 is a nice number to try because it cancels out your variable term. Is negative 2 less than 10? And that is yes, that is a true statement. So at the point 0 means we're going to have solutions. So that means our line goes to the left. So all values of x that are less than 4. That would be our solution, and then you have the number line as well. All right, part B. 5x minus 1 minus 3x is greater than or equal to 4x plus 5. Let's combine our like terms. That would be 2x minus 1. We're going to change it to an equation, is equal to 4x plus 5. And then we will go ahead and solve for x. Get the variable term on the same side, and then get the constant on the same side. So we get negative 2x equals 6 divided by negative 2, and x is equal to negative 3. So on this one we have 0 and negative 3. Is it open or closed? Well, on this inequality it is equal to, so we will do a closed circle at negative 3, and then we need to figure out, are the points to the left of negative 3 solutions or point to the right? So once again, we're going to continue to test x equals 0 as long as it's not a boundary point. And we'll plug that in. And this time, I'm just going to look at it because all the variable terms are going to cancel. This would be a 0, this would be a 0, and this would be a 0. So what does that leave me with? Well, it leaves me with negative 1 is greater than or equal to 5. And therefore, negative 1 is not greater than or equal to 5. So no, that is not true, which means at the point 0, that is not a solution. So therefore, we need to take the points to the other side, which is to the left. So that means our solutions are all values of x that are less than or equal to negative 3. All right, moving on. C, we have, I'm going to go ahead and distribute. 2x plus 2 is greater than, well, let me go back. Let's try this again. I'm not going to distribute. I'm going to rewrite it as is, and then we'll go to the next step, so we're not confused. So 2 times x plus 2 is greater than 10 minus x. So we can distribute. That'll give me 2x plus 4. We're going to change it to an equal sign, so we can find that boundary point. Get the variables on the same side by adding x. So 3x plus 4 equals 10. Subtract 4, divide by 3, and x is equal to 2. So, 0, 2. Do we include the solution 2 or not? No, because it's not equal to. So we'll do an open circle, and then we'll test the point 0 again. So this will be 2 times 0 plus 2 is greater than 10 minus 0. So this is just going to be 2 times 2, and that is 4. Is 4 greater than 10? No. So at the point 0, it is not going to work. So now we need to go the other direction to the right. So that is all values of x that are greater than 2. All right, and on to the last one. D. D is 4 times x minus 3 plus 5 is greater than or equal to negative 7. So let's distribute. 4x minus 12 plus 5 is equal to negative 7. Once again, changing it to an equation. 4x minus 7 equals negative 7. Add 7. and we get 0 divided by 4, and we get x equals 0. So in this case, 0 is our boundary point, so we can't test 0. It is equal to, so we do want to go ahead and do a closed circle at 0. Well, now I can't test the point 0, so probably the next best point to test would be 1. Or in this case, we actually could do 3, because 3 minus 3 is 0. So maybe x equals 3 would be even a little better on this one. So let's do x equals 3, because what happens is you get 4 times 3 minus 3, which is 0, plus 5 is greater than or equal to negative 7. So that's just going to cancel out. 5 is greater than or equal to negative 7. Yes, it is. So that means, where is x equals 3? That's over here. So that means it is true, which means our line is going to go to the right. So all values of x that are greater than or equal to 0 would be our solutions. Question 71. Algeria has decided to take out an advertisement in the UN newspaper, Liberty Daily. The newspaper charges a base fee of $1,200 for an ad. There is an additional fee of $300 for every inch in height. If Algeria is willing to spend any amount up to and including $2,700, what choices does the country have for the height of the ad? So we need to identify what it is that we don't know. Well, we don't know after the base fee of $1,200 what the height of the ad is going to be. So let's say that we're going to let h equal the additional height of the ad. All right. And then we have to decide, okay, we have a base fee of $1,200. So it's going to cost that no matter what. So we got $1,200. And then we're going to add the additional fee of $300 for each inch. So for each additional inch, and by the way, the height is in inches. So that means we're going to add an additional $300 for each inch that is added. So $1,200 plus the $300 times h. They're only willing to spend an amount up to and including $2,700. So not $2,700 exactly, up to and including $2,700. So this amount could be anything that is less than or equal to $2,700, because they're willing to spend $2,700, but not anything above that. So now that we have the inequality written, now we can go ahead and solve for the h value. So we will subtract the $1,200. So we have 300h. We'll change it to an equal sign so we can figure out that boundary point again. So 300h is equal to 1,500 divided by 300, and h is equal to 5. All right, but we need to answer the question. What choices does the country have for the height of the ad? Now, even though we changed it to an equation, with applications, sometimes we just need to think about, what makes sense. Well, if h is 5 and we can include the 2,700, it would include the 5, but if we keep adding inches, it's going to keep adding money to the cost. So if we go above 5, it doesn't make sense because our cost is going to go up. So it appears that we can do anything that is less than 5. Obviously, we're not going to get into the negative, so it does have to stop at 0, so we don't have to add anything, but we can go up to 5 inches in addition to the ad space that they're already going to give us. And so to answer that question, I just said Algeria can order an ad up to 5 additional inches high. So anything beyond the base fee of $1,200, you can add another 5 inches, and they won't go over the $2,700 that they want. Question 72. If the graph of an exponential function passes through the points 1, 6, and 4, 48, find an equation of the function. Refer to the math notes box in this lesson if you need help. So we've done these problems before, but if you look at the math notes box, it'll go back and kind of re-explain that. We've done this a couple of different ways. One, we did a table, and we would just think, okay, if I plug in 1, I get an output of 6. I don't know what 2 and 3 are, and then 4 gives me an output of 48. Now what we do know, it's exponential. So what that means is something is getting multiplied each time to get to that next number. So we would have to take 6 times that same number 3 times to get to 48. So we can set that up and say, okay, well, 6 times b to the third power, b times b times b, should be equal to 48. And then now you can divide, and you have b cubed equals 48 divided by 6 is 8. And then now you can just think what times itself 3 times gives you 8, or you could take the cube root of b cubed and the cube root of 8 to get b is equal to 2. So we know that the b value is 2. We also know that the first term is 6. So we can decide, do we want to use first term form, or do we want to go back to term 0? If we want to go back to term 0, that's fine. Then you have to divide by 2. So your first term would be 6, but your 0 term would be 3. So it all depends on how you want to write that. So I would say t of n, well, it says exponential, so let's write it as just maybe y equals. Y equals, your initial or term 0 is 3, your multiplier is 2, and then we could raise that to the x power. If you choose not to go back to term 0, then you still have your term, but you're going to be looking at your first term instead of your 0 term, so that'd be 6. Your multiplier is still 2, but then you would subtract 1 from your exponent. So if you plugged in 1, it would be 6 times 2, 1 minus 1 is 0, which would give you 6. So either way is fine. Once again, it doesn't say specifically which form you want to use, so this would be considered, I guess if we want to call it term 0 form, whereas this one would be your first term form, which would be term 1. Okay, so either one's fine. Now, if you do go and look at the math notes, they did it slightly different. They set up some equations and solved the system by knowing that these ordered pairs were x and y. But once again, either way is fine. You can look at the math notes or kind of go off the video here. Question 73. Line M has intercepts negative 7, 0, and 0, negative 2. Find the equation of the line M. Is the point 49, negative 16 also on line M, and how do you know? I think there's a couple ways you could approach this. It does give us 2 points, so we could figure out what the equation of the line is first and then figure out the point. Maybe graphing it, some of you might think of as well. We are given negative 7, 0, which is the x-intercept, but you're also given 0, negative 2, and that's the y-intercept. So y-intercept is one of the points that we can use for our equation, but we do need to still figure out the slope. So we can do the slope as the change of y over the change of x, or you can use your table. Either way is fine. 2 over negative 7, or negative 2 sevenths. All right. So we know our equation is y equals our slope of negative 2 sevenths x, and then the y-intercept is minus 2, or for that point. B, is that point also on the line? Well, how do we figure that out? Well, we can plug in 49 for x and negative 16 for y and see if it is equivalent. Negative 16 is equal to negative 2 sevenths times 49. I'm put it over 1 so that we can multiply, and then minus 2. So let's see what happens. Does the right side equal negative 16? So on this one, we can actually cancel. 7 goes into 7 once, and 7 goes into 49 7 times, not 2. And then negative 2 times 7 is negative 14. Negative 14 minus 2 is negative 16. So is the point on the line? Yes. And how do we know? Because we plugged it in and they were equivalent. And so I just substituted x equals 49 and y equals negative 16 into the equation, and the statement was true. So that's how I know that it is correct. Question 74. 2e made the following hypothesis. 2n minus 1 is less than 5, and n plus 1 is less than or equal to 2n. Which of the following conclusions can she make? Well, what we probably need to do is go ahead and solve both of the inequalities. We'll start with 2n minus 1 is less than 5, so we'll rewrite it as an equation and figure out what that boundary point is. And so if we divide by 2, we get n equals 3. So we know on our number line that the 3 represents our boundary point. It is open because of the inequality does not include equal to. And then we're going to test a point. We're going to test the point 0, or x when x is 0. So we get 2 times 0 minus 1 is less than 5 is negative 1 less than 5. And that is a true statement, so therefore we will shade or go in the direction of 0, which is to the left. So those solutions represented are when n is less than 3. So if you look at the answers, we have a couple answers that are n is less than 3, but we also have these two that are equal to. So it seems to be that A and C would be out at this point. Let's go ahead and solve the second one. And so the second one, we have n plus 1. And once again, we're going to change it to an equation. So we can subtract the n. 1 is equal to n. So we know on our number line that at 1, this one is going to be a closed circle because we do have the equal sign, so it is part of your solution. And then once again, we'll test at x equals 0, or n equals 0, I guess is what we should be saying. So n is equal to 0. I'll change this one over here also. And when we plug in 0, we get 0 plus 1 is less than or equal to 2 times 0. So is 1 less than or equal to 0? And no, that is not true. So therefore, we're going to shade in the other direction. Since at 0 it's false, we want values of n that are greater than or equal to 1. So now look at your choices we have left. We have n is greater than or equal to 1, or D is n is greater than 1. So it appears that B satisfies both of the inequalities, where it's greater than or equal to 1, but also less than 3. Question 75. Multiple choice. Which of the following expressions below is a factor of 6m squared plus 7m minus 5? Well, to figure this out, we just need to go ahead and factor this problem and see what factors we get, and then we can pick out which ones represent the factors of the polynomial. So 6m squared, and then we have a negative 5, so we multiply those together to get negative 30m squared. And then we need something that adds to give us this plus 7m. So what are factors of negative 30 that can add to give us 7? What about 10m and negative 3m? And so we'll place those in our generic rectangle and figure out the side lengths. So we need to get the 6m, we'll need a 3m and a 2m, and we've got to make sure we put them in the right spot so that we can also say 2 times what is going to give us 10. So 2m times 5 is 10m, and then 3m times negative 1 would be negative 3m. So it looks like our factors are 3m plus 5 and 2m minus 1. So take a look at our choices here. 2m plus 1, that's not correct. m plus 5. That is not correct. 2m minus 5, nope. And then the last one, 3m plus 5. As you can see, that's our first factor we wrote down right here. So that's the one that represents a factor of the polynomial 6m squared plus 7m minus 5. And question 76. For the quadratic function f of x equals x squared plus 6x plus 11, use the idea of completing the square to write it in graphing form. So if we want to write this in graphing form, we need to complete the square. So we have, to kind of give you that visual, we have x squared. Alright, and we have 6x. So we have to break this up into equal parts. So that'll be 3x and 3x, which means our side lengths will be x plus 3 and x plus 3. Now, we need 9 tiles, but we have 11. So we have too many. So we're going to subtract 2. And we got to do it from both sides so that we get those 9 tiles. So we're actually going to have f of x minus 2 is equal to x plus 3 squared. So that's the side lengths of the rectangle. And then we're going to add 2 back to the other side. And we get f of x equals x plus 3 squared plus 2. So that is graphing form. Remember, graphing form is f of x equals a times x minus h squared plus k, where our vertex is hk. So B says state the vertex and sketch the graph of the parabola. So in this one, our vertex, it's x plus 3, so that'd be x minus a negative 3, so h would be negative 3, and k would be a positive 2. So at negative 3, 2, That represents the vertex. We also know, to help us figure this out, we know the y-intercept is at 11. Go back to your original. When you plug in 0, you get 11. So this only goes by 10, but 11 would be right here. And since our line of symmetry is right here, we know that also there should be a point at 6, 11 as well. And so that will allow us to sketch the parabola. Now part C says use the graph to explain why the equation x squared plus 6x plus 11 equals 0 has no real solutions. Well, you can see that it doesn't cross the x-axis, so therefore there are no x-intercepts, which means there are no solutions or no real solutions. And so that answers part C. The parabola has no x-intercepts.